Now, dear students, we want to explain motion in a plane. So, to explain motion in a plane, we have to think about the position vector, displacement vector, then we will discuss about velocity, acceleration. But now, we'll think about all these physical quantities in vector form. So, first let's discuss position vector. Now, suppose as shown in this particular figure, we consider any point P in two-dimensional Cartesian coordinate system. Now, for this particular point P, prepare the position vector from the origin. So, OP, this particular vector prepared here, that we can say the position vector of particle P, which we can represent as vector R. Clear? Okay. So, R, that is the position vector of point P. Now, here, suppose we draw a normal from point P to x-axis, that is PM, and another normal to y-axis from point P, that is PQ. So, here now we can prepare two vectors. One vector, that is vector OM, and another vector, that is vector OQ. But this OQ vector, that is equal to MP vector. So here we can write, if magnitude of OM, that is x, because it is on x-axis, so we can take its magnitude equal to x. And for vector OQ, if we take magnitude is y, then for MP, magnitude will be y. So we can write vector OM, that is its magnitude into I caret, because it is in x direction. So simply we can write that is xi caret. And MP, which is in y direction. So magnitude of MP into j caret, magnitude is y. So we can write it is y j caret. Now, as per summation rule of vectors, you can see this OM, then from head of the OM, there is the vector MP. So, vector joining to the tail of first one to the head of second one, that is OP. So, we can say vector OP is the summation of these two. So, we can write simply vector R, that is equal to xi caret plus y j caret. So, in this way, we can represent the position vector. Or simply, in other words, we can say, if in two-dimensional Cartesian coordinate system, if we consider any point P, which one have coordinates xy, this one is the x coordinate, this is y coordinate. So simply, you can write its position vector as r equal to xi caret plus yj caret. That is very simple thing. Now, direction of the position vector. So, direction that always we represent with respect to x-axis. So, suppose here, with respect to x-axis, the angle made by position vector r, that is theta. So, if we take tan theta, then that is opposite upon adjacent. So, tan theta, that is y by x. So, we can write theta, that is tan inverse y by x. So, in this way, we can find the direction of the position vector also. Now, magnitude of the position vector r. So, here suppose magnitude is r. For position vector r, the magnitude is r. Then simply using Pythagoras theorem, we can write r square, that is equal to x square plus y square. So, magnitude of vector r, that is under root x square plus y square. Now, simply we can extend this one in 3 dimensions. So, in 3 dimensions we can write position vector r for any point or particle, that is xi plus yj plus zk, and its magnitude that we can write under root x square plus y square plus z square. क्लियर बच्चों? अब देखते हैं डिस्प्लेसमेंट. ओके, Now, displacement vector. So, suppose we consider the motion of any particle in two dimensions. In xy plane, suppose one particle is moving on this curved path, which one is represented by this black curve. Okay? Now, arbitrarily, suppose at some instant t1, the moving particle is at position P. Its coordinates are x, y. Then after, suppose at some instant t2, the position of that particular particle is q. Particle is moved on this particular curved path like this. Okay, on this particular curved path. And at time t2, it reaches at position q. Suppose for this particular position q, the coordinates are x dash, y dash. Now here we can say this thing, at time t1 position vector of the particle, that is r, and at time t2 position vector of the particle, that is r dash. Clear bachcho? Now we have to think about the displacement vector. Now see here, our vector r, that we can write xi plus yj, and vector r dash, that is x dash I caret plus y dash j caret. Okay, so in this way we can write the position vectors. Now displacement vector. So displacement, that is the vector joining to the initial to final position. Okay, so here the displacement delta r, that is the vector pq. Now this particular vector pq, that we can find by taking r dash minus r. So we can write the displacement vector delta r, that is r dash minus r. But r dash, that is what? X dash I caret plus y dash j caret. Then r, that is minus xi caret plus y j caret. Now here, suppose first we take xi, x dash I caret minus xi caret, and if we take I caret common, then simply we can write delta r, that is x dash minus xi caret. Similarly, y dash minus y j caret. So this one is the difference of x coordinates. This is the difference of y coordinates. So x dash minus x, that we can represent as delta x. Similarly, y dash minus y, that we can represent as delta y. So delta r, that is equal to delta x I caret plus delta y j caret. So here displacement of particle in time interval delta t, t2 minus t1, that is delta r, which is equal to delta x I caret plus delta y j caret. So in this way we can prepare the displacement vector. Clear bachcho?